Yep. So you should be able to see my screen now. Can you see it?
Yes.
Yeah. So yes, we have gone through a good number of sessions so far. Today's session number 8. This was what our last schedule looked like. There's been some changes, as you can see. We have new dates. So from introduction, talking about computer science, information systems, and information technology. We also talked about career paths, hardware, software, internet and web, cybersecurity databases. Last week, we talked about cloud computing, just the big picture. So, oops, is my video on? I don't think so. Yeah, it's not. Yeah, it's very cold out here today, so I have my beanie on. It's
I see.
yeah. But anyway, so we're going to talk about software programming today. Okay. So let's see, what is software programming? Again, we'll talk about just the big picture, a few things we need to learn about, not actually coding today, because we have to just learn the fundamentals. So that's what we're going to cover, the concepts and the basics. And this is what our outline looks like. SDLC, just mention it in passing, because again, we're developing software. Software, again, is what complements hardware. Computer is made up of hardware and software. And in order for us to be able to input and get outputs, we need software to be able to process that, to do a particular thing that we need. And we need dedicated, should I say, technicians, or should I say dedicated people who are known as developers, to be able to develop this software for us to meet a particular need. So we'll talk about that life cycle. We'll talk about coding fundamentals, the types of programming languages, and the types of programming in general, as well as some basics and where you need to start if you really want to get into software programming. It's a good idea to have it's good to have a good idea of how all of these work before, while you're in the IT field, so that the terminology doesn't sound abstract to you, and you should be able to gather from there. So that's all I have in there for the beginning part, just some of those pictures, and there's some notes in there if you want to take a look at those as well. But yeah, that's for software programming. And yeah, the most important thing we need to do is get into that sheet. Oops, I already had that open anyway. Never mind. Let me close that. Okay, so here it is. So today, like we said, the overview, we wanted to make sure we talk about these 5, or should I say 6 things. Software development lifecycle, coding fundamentals, and so on and so forth. So an estimated timeline. We're already 10 minutes in to the day. So again, SDLC is just like the life cycle of every living organism, the processes that you have to go through. If you have someone would like to get a particular software developed for them, the first thing you have to do is plan, right? So after planning, discussions with the person that needs the software, the person that's going to build it, stakeholders, and so on. And the project manager, they come up with, okay, what product they need, because, based on the specifications, come up with a timeline, come up with a budget, come up with constraints, and, things that are important, a whole list of requirements. So with this needs analysis, they come up with needs of requirements. I need my software to be able to get the date and then schedule an event, or maybe I need a software to be able to take a picture and then add a text to the picture, or I need a software to be able to get a username and password and so on. All those things make up what is known as the requirements. that are being gathered in the needs analysis. Now the developer takes that information, goes down, uses software programming knowledge, a particular language based on the industry that they're working. If your company is using a particular type of software or servers or database, then you have to use the language that works with that. Okay. If it's open source, if it's something that you get to decide, then okay, it depends on what your requirements are. Is this software going to be software that you need for mobile device? Is it software that they want to see on a web browser? Is it software that they want to install on their machine, and privacy concerns, security, and so on? So all of those are taken into consideration. So that developer now builds that software, which is known as the creation phase. After building the software, you have to be able to make sure that it does what you need to do. If you're building a calculator, you want to make sure that if you're adding 1 + 1, it should be 2. If you're adding 2 + 3, it should be 5. So you have to go through the testing phase. You test that the code is doing what is expected. You test that all the features are there. You test that it's integrated together. There are different sets of tests that are being done. So all that validation is in there. You want to make sure if the person is expected to enter a password, the password is blocked. If the person is expected to enter an age, they should enter a number, they should not enter a letter, and so on and so forth. So all those things are being tested. So all of those is what make up a software development life cycle. And after testing, you have to go ahead and deploy, give it out to your operations team, the person that requested the software, to work on it. And then they'll keep monitoring it, seeing what things need to be changed or updated or removed or added, and also maintaining it, making changes to make sure that the entire life of that product is long. So that's exactly what the software development life cycle is. If you take a quick check on for SDLC, there are different versions. Every company has a different way of doing theirs. Some companies might have a waterfall method, you get from the start to the end. Other companies have a different methodology or a different paradigm. They do everything in 2 weeks. They need to build one feature and build another feature and so on and so forth. So it depends on the company per se. But again, the main thing is you start with, let me open this larger so we can see. The main idea is starting with, okay, let's see, come on. Okay, there we go. Yeah, so the main idea is starting with the planning. Once you're done with, oops, that's not the one I wanted. I wanted this one. Okay, my computer is not being very nice to me today. Let's close that. Let's open this. There you go. So again, you start with planning. After you planned everything to make sure it meets your requirements, you analyze it, you design it, implement it. Designing might be just drawings and mock-ups, or making sure that the infrastructure is what you expect. If it's a website you need to build, maybe draw a mock-up of the website. I need this picture to be here, I need this button to be there, and so on. And then show them. Once the design is in there, you go and build a functionality. And then you do your testing and integration, maintenance, and so on and so forth. So again, there are different versions of this depending on the company. If it's a big team, then you might have many different people working in different pieces. If it's a small team, you might have one person working the entire life cycle. But at the end of the day, that's what you do to develop your product. Okay. That said, let's carry on to coding fundamentals. So again, what exactly is coding? I know the term says software programming. What is software? Software could be a program. Software can also be an application. Okay, so software could be a program or an application, but then when you talk about programming, programming is really large. We're going to talk about the different types of programs. We're also going to talk about the different types of programming languages. But let's go in and talk about the fundamentals of coding per se. So if that can take me to the right page, I believe so. All right. So the previous class, we talked about hardware and software. What is hardware and what is software? So let's take a look at some of these pictures while I describe what exactly we're talking about here. Come on, open up. It's still taking its time. But any questions so far? Nothing yet. Okay. So let's see. Come on. This is horrible. It's so slow. Let's restart this computer. That's going to take too long. Then I'm just going to open it directly from the file. Let me share another screen that has a better view in there. Oops, there you go. Never mind. Okay, so let's see. I think I just lost my screen here. There we go. All right, let me know if you can see the screen.
Yes.
Okay, awesome, awesome. So this looks like a bunch of gibberish, right? But this is just an example of what code looks like. Those are different types of programming languages, right?
It's so scary.
Yeah, but it's not a big deal. By the end of the day, you'll be more comfortable when you see something like this. So on the left is one type of programming language. You also call that a source code. You know, you call the program itself that you type a source code because it is where you're going to develop the not the hardware, the software from. Okay. So again, if it's something that is proprietary, then you're going to not share this source code. But if it's something that is for anybody that you don't care if people make changes to it, then it becomes open source. That's where you get the word from, open source, which is open source code. You can actually look at the code. So this code again is it looks something like this. And am I looking at the right one? No, I went to the wrong one. That's why. Coding fundamentals. Yes, that's correct. Okay. So that is an example of what the code looks like. But what is source code? It's a collection of computer instructions that we have written it in a way that human beings can read it. Now it has to be changed to a computer language, a computer's code, which is known as machine code. So again, source code is that collection of computer instructions that's written using some human readable computer programming language. And it's plain text. As you can see, those are texts that we can read, but we don't necessarily understand. Now, okay, this is really horrible. What exactly again is it? These are just steps. Just like if you go about trying to cook a particular dish, or let's say you want to bake a cake, right? You have a recipe that you have to follow. The recipe will give you ingredients or requirements, the sizes, the quantities, you know, if it's cold or hot, warm, and so on and so forth. And then it lists all the steps. It's the same with the programming language. A programming language is just giving these instructions to the computer to do what needs to be done. So there are different types of editors. Okay, editors is just like Notepad, you know, what you actually use to enter the code. Okay, so again, there's so many of them, we cannot list all of them here, but these are just a few of them. So with an editor, all you do is type your code, the command, it does what it's expected to do, and then it sends that information to the computer. Now, this is really painful. How do you write it? You write it again, just like I showed you those other ones in plain English. You use particular keywords to write it. And most of the time you see source code is written in green text and black background. Okay, that's just because the command line has that same type of function. We don't really need to make it pretty. We don't need to make it red, blue, yellow, and bold, underline, because it does not, it disregards all of that. We just need particular plain text, and we don't even need a particular font. You see, different fonts have different sizes, but for computer source code, or for source code for computer programming or software programming, the one that is usually used is monospace font. The main reason that is being used is because when you want to be able to look at your code, you see that it's evenly spaced. Each letter has the same length as width, rather, as the next one. So you can easily see that this space is 2 spaces, this is 2 spaces, and it's all the same. And you can see that this has 2 letters longer than the other one because it's evenly spaced. If you use the other types of fonts, like this, which is not proportional, you can see this M is longer than the I, this A has wider width than the L. But with this case, they all have the same width for that font. So that's why computer programmers use the monospace font, which makes it easy on the eyes to read as well. So it's exactly the same. All right. Now, what is a computer program? Computer program, like we said, it's a list of instructions you write using a computer programming language that the computer understands. There are many, many programming languages. Just like in life, there are many different languages. Every country, every village has their own language that they use, right? Now, that said, what is it that why do we actually need this? Why don't we just tell the computer, play music, or, send an email, and then it does it? The computer doesn't understand that, okay? What we do is we write it so that the machine can understand it. So the entire point of having programming languages is that you don't have to write machine code, because the machine understands only machine code. Us now, we have to write this code in a programming language that can be transformed into machine code. So you look at everything that has a computer chip in it. Our laptops, desktops, cell phones, servers, or video games, all of them have what is known as a CPU. The CPU is the most important part where the program is being executed. Okay, we can talk about the history of the CPU. We talked about some of it with hardware. It's just a lot of transistors that are passed together, a bunch of them, a million or billion of them in some cases, okay, depending on the type of CPU. If it's i3, i5, Intel Core, and so on. That's why most of the time they'll ask you, you want to buy a laptop, what's the CPU capacity, and so on. So what happens? Go ahead, come again.
A CPU can have up to 1 billion transistors.
Yes, yeah, a lot of transistors in there, and that's what actually takes those instructions and actually execute them. Okay, so that's where your program is executed. All that code that you're writing is going to go in there. So how does this happen? Okay, when you write your code, right, this is you on the left, you've written your source code. That source code needs to be converted to machine code, because this CPU understands only machine code. In order for you to do that, you have to then go ahead and, I think there are too many pictures in this folder, that's why. You have to get your source code to actually compile. That's one option. Write the source code, compile it, it transforms that into machine code. That machine code now can get sent into the person's computer using like an exe file. So if you notice back in the days, or even currently, most of the programs that you execute are .exe files, because that is machine code that has been compiled from source code that somebody wrote. Okay, so that's one way of doing it. Another way of doing it is by using what is known as an interpreter. In that case, you write your source code, you send that source code to your computer or the person that wants to use it, and then the person has an interpreter on their computer or the browser or whatever they're using. That interpreter usually comes with the computer when they buy the computer.
Okay.
The interpreter then converts your source code to machine code, and then it can execute what needs to be done.
So the interpreter is a software.
Yes, the interpreter is already built in your operating system. So if you have a Windows operating system or a Mac operating system, it has an interpreter in there. So sometimes you have to write code that is specific. If you will not want them, maybe the interpreter is not in there, they need to update or upgrade it, okay? The third one, which is not very, very popular, but it's getting more important, is just-in-time code, okay? So again, we'll talk more about this later on, but you can either have a programming language that is a compiled programming language or an interpreted language. The compiled ones, of course, are faster because it has already been compiled. All the errors have been discovered and cleaned. Now you know your code is running okay. But for the interpreted one, you have to actually check if the error is there while you're executing it, okay? Mm-hmm. For compiled languages, you have to use a specific platform. Is it for Windows or Mac and so on? But for interpreted languages, it works on every platform. So again, think of that compiled language. Are you going to get .exe file? .exe file is not going to execute on a MacBook or a Mac computer. For compiled languages, again, your source code is not shared. For some people, it might be a good thing, it might be a bad thing, But do you want it to be open source? Do you want it to be proprietary and so on? But interpreted languages, your source code is actually shared. So you can actually run your compiled language easily because it's already in machine code, but interpreter requires a computer to be able to do that. So those are some of the small examples in there, just to discuss that. Like I said, the third one is the intermediate, where you have just-in-time compilation. In this case, you actually compile to an intermediate state, which is known as byte state. And then from there, when the computer actually needs to execute it, it's just going to run it just in time to change it to machine code before actually doing it. Yeah. Do you have any questions on that?
No question for now.
All right. So we haven't talked about any programming languages here, but here are some examples of compiled languages, interpreted languages. We'll talk about them again later on, but I don't want to take too much time on that. I think we've already taken too much time on it, but again, what does your CPU need? Your CPU gets some of its commands. It has some memory in there. It needs a memory chip. The memory is where all your data is going to be stored for your application. Application, again, is another word for software. So normally, like I said, the transistors, they are usually either having electricity going through or electricity not going through, right? If electricity is going through, then it's in the on position. If not, it's in the off position. So for each switch, you basically have two values, right? Either on or off. Now, if you have just one transistor, that's what you have. But if you end up, oops, I'm going backwards again. If you end up having two transistors, you have four values because you can have off, off for both of them, off and on, or on, off, and on. So with two transistors, you can have four different values. But now if you double that, if you add one more value, each time you add a new transistor, the number doubles. So it changes from 2 to 4. Now you have 8. If you add another 1, which is going to be 4 transistors, or 4 switches, you end up with 16 different arrangements. So at the end of the day, when you get to all the way to about 8, you have 256 different arrangements that you can have. Does that make sense?
Mm.
So
a little bit complicated.
A bit complicated.
Yes.
Okay, let's try to make it easier. Okay. So if you have off, on, right? You have 8 boxes. You can actually use permutations or combinations. If you have 8 switches, you can decide to have all 8 of them off, and then you start changing all 8 of them on, and start changing each one, and so on and so forth. If you see all of those different combinations in which that electricity can go through those transistors, that's how you come up with 256 different arrangements, okay? So what does that mean? In computer science terminology, instead of using on and off, we use 1 and 0. 0 is the absence of electricity, 1 is the presence of electricity. So you can actually have all zeros or all ones and so on and so forth. And each of those is known as a bit. A bit is binary digit, right? Binary digit. So it gives you a bit. So 8 bits gives you 1 byte. So 1 byte of data is that size in there. So you can imagine what it means when you have 8 bits gives you 256 possible values, right? That's for 1 byte. For 16 bits, you have 65K different values. By the time you get to 64 bits, right? That tells you how much data a CPU can process per minute. So you want to see how fast is your CPU. You know, it depends on the bits per minute, or bits per second, rather. Okay, so that's just to give you an idea to see how much data you're having. For 32, you're looking at 4.3 billion possible values. But we are looking at 64 bits. Yes.
Yeah, how do I, if I have to check my CPU to know the bits conversion rate per minute, how do I get to that?
It depends on the operating system you're using. I'm using, this is a Mac. If I go to my system, or if I look about the Mac, it's going to give me my gigabytes. It's in gigabytes in this case, okay? But normally, if you go through the computer's properties, you should be able to see that. And again, depending on the size of the computer, if it's a fast computer or slow computer, the processor and so on, then you should be able to tell. Sounds good?
Okay.
Yeah, but I know we're going to talk about programming languages, but it's good for us to get the basics, right? So at least if you know that, you know, you can set up your computer to come up with a particular order, then maybe you can build a spaceship like this that you can use in your video game. So you just have to make sure that, okay, you give this instruction to the CPU, like, hey, give me an image that looks like this, you know, and so on and so forth, and then you're good. And then once you do it once and, you know, one too many times, it becomes a habit and people can copy it, and you can also copy yourself and make it faster. So that's the whole idea of actually building computers, right? But if you look closely, you see that with the machine language, we did not have ones and zeros. We had some different types of funny numbers. Those are actually ones and zeros. They are just represented differently so that they don't take up too much space. If you look at this screen, 27 is the same as 27, is the same as the Roman numeral, is the same as counting this and crossing every 5. Or if you want to have 27 bananas, those are all the ways you represent it. It's the same thing with machine code. With machine language, or should I say machine code, instead of using 8 spaces to denote the bits, we're actually using just 2 to get hex. So hex actually is counting from 0 to 9 A to F. So 0, 0 means all the 8 bits are 0. FF means all the 8 bits are 1. And if it's 1, 0, 0, 0, that would be 8, 0, and so on and so forth. So those are all examples of how you get it. So most of the time you see hexadecimal is being used as the digits of the representation for machine code. And you can see how much space you're saving if you use that. Sounds good?
Yeah.
What other questions do you have?
No, for now.
Awesome, awesome. So yes, that takes us to the first part of, just talking about the fundamentals. That's what we're doing. Everything we're typing is going to be converted to that hex. The hex is going to send it to the CPU. The CPU is going to execute it. The CPU is really, really fast. Okay, it's got so much speed. It's just going to keep asking us for input. As much as we keep giving it, it keeps running its computations and executing. Sounds good?
Yeah.
Awesome. Well, let's talk about the different types of programming per se. So we've talked about what programming is. The different types of programming, we talked a little bit about compiled versus interpreted, right? If your code is compiled before it's sent to the computer, then, it has its benefits and so on and so forth. But here are other ways you can distinguish between programming languages. You can have a scripting language, you can have a markup language, and you can also have programming language that runs on the client and another one that runs on the server. The client is usually our computer that we are using to get information from another computer. So if you're getting information from a website, the website host is the server and you're the computer. If you're getting information from another database, that database is the server and you are the client. So let's talk about some of these differences here. Oops. All right, there you go. I think that's too big. Let's make it smaller. Okay, so compiled languages, as it says here, the compiler generates, or the compiler generally generates this machine level code using its translators, right? And there are a few examples of the different programming languages, but the interpreted language, the interpreter executes a program line by line. So for compiler, it bunches the whole program. You have your whole book, it takes the whole story, digests it, and then tells you this is the story. But for interpreter, it takes each line of the story and tells you, takes each line, tells you. So if it gets to the part that the line has an error, it's going to stop there. That's why, for instance, it's not as fast as the compiler. Compiler, you're already done with the story. Now you're telling someone else, right? So it's like you have gone to school, you have already read the book. Now you're explaining it to somebody else. Or, it's in the evening, the kids have to go to bed. You take their storybook, you read each line, and then you tell them, you read each line, and then you tell them, and so on and so forth. So those are the differences. And here are some examples. Java is compiled, so Java runs faster than Python. For the most part, C#, C, and C++, they are all compiled languages, so they run faster than these interpreted languages. Now, this next one was the scripting languages and markup language. The scripting language, again, is just to execute independently over any other application per se. So it's used to make mostly automation, right? So if you know that you have, you come into work, you're going to log in, you're going to email person A, email person B, email person C, then you can go ahead and create a script that's going to do those tasks for you, okay? So you're just automating things that you need to do. So if you know that when I open my computer, I'm going to open this file, open this folder. If this file is there, copy this file to this other location. If the file is not there, go to another location and copy it. all those different steps, you can outline them using scripting languages. So these are some of the examples of scripting languages that you can use, and it's going to automate that for you. All you have to do is just run the program. The program does all of that for you while you're doing something else. You save yourself time. And it also makes it very error prone. Humans usually make errors easily. So if you do it that way, you cannot have errors. Markup language, again, it's an artificial language. Some people say it's not real programming, but that's just for annotations, for making text distinguishable, and so on and so forth. Okay, so take for example HTML. HTML marks up your document, right? For instance, if you look at this page, this is bold, so that has been marked up to be bold. You can also mark up this one that says example. I can decide to change the color to red. That's markup right there. If I come in here, I can decide to say, okay, I want to change the background to yellow. I'll go in and do that. Oops, sorry, my mouse is not cooperating. And that's another markup. So that's why it's not really like a programming language. It's just for you to distinguish text and how you want it to look on your page and so on and so forth. So that's a different type of programming language. It's usually the easiest one to get started with, if you want to learn HTML, CSS, because you can actually see what you're doing. And then it makes more sense to you. You can catch your errors. The three big ones that, oops, I keep going back. Yep, I knew I was gonna go there. The three big ones that we need to talk about, that are very popular are functional languages. I missed the first one. Procedural languages, functional languages, and object-oriented languages. So for procedural languages, again, it's just step by step, right? So procedure is nothing but a set of functions that you have to follow stepwise, right? So it makes this program structure and easily traceable for program flow. So think about, again, your recipe. You just have to follow the steps of the recipe. It's the same thing with that. And there are a few examples here we can look at later on as well. For functional languages, the focus is that on the functional programs are, to make the so-called functional languages impure and contain imperative features per se. So I think this is mostly, Haskell is the most popular of all of these. It's not very popular, again, because what is actually really used often in the real world is object-oriented languages. Because in the real world, everything is an object, right? A car is an object. What an object is, it can have a form, okay? It can contain data. It has a form field known as attributes, and it can actually perform a particular thing. So it can do something. For instance, a car can go forward, a car can go reverse, a car can honk, and you can also take an example of a student. A student can attend a class, a student can write an exam, a student has a name, a student has a number, and so on and so forth. So an object usually has something and does something. So if you have something and you can do something, then you can consider that an object. All right. I think that's about it for most of the different, oops, let me go back to that. The different types of programs, right? So we can have compiled, interpreted, scripting, markup. We can also have structural, functional, procedural, and object-oriented programming. There are lots of other ones, but we can focus only on those because they are about this. Also, query language, where you have SQL, there's other different types of languages, just too many, even mathematical languages like R and so on. So the next one is going to be talking about, let's talk about the languages per se. So for languages, that also there's a huge number of them, okay? There's a website that usually publishes every month the popularity index of each of these languages. Okay. So as you can see, let me zoom in here a little bit. As of October 2022, Python is the most popular of all the languages. And then you have C, Java, C++, C Sharp, Visual Basic, JavaScript, and so on and so forth. Okay. So it also gives you a trend. They've been doing this for quite some time now. So if you scroll down, you'd see there's actually a graph that shows you from 2002 how each of them has been going. If you check on Python, it shows you Python was really at the bottom in 2002. It's rising all the way to the top. Okay. If you say C Sharp, you click on it, or if you can put your mouse on top of each, it tells you which one is which. And that's for C. This is for Java, and so on and so forth. That's C++. So again, this is just for the popularity. They actually tell you how they go about doing it. You know, they check for the number of searches from search engines and so on, about 25 different search engines. As you can see, these are the top 20. But if you scroll down, you see that there's more of them, you know, from position number 21 to 50. But again, these all usually fall into one of those categories that we just talked about, okay, based on how many people are using it, okay? And then there's more and more and more and more. But that's about it for different programming languages, you know. Depending on what field you're going to get into, what you're interested in, you might never see some of them in your life. I don't know up to 20 of them personally, you know, by name that is. I know maybe 3 or 4 or 5 that I can read and understand. Just like in life, if you're never going to go to Russia, you don't need to learn Russian.
That's right.
Right? If you're never going to go to Japan, you don't need to learn Japanese. But if you see somebody writes Japanese, okay, you say, this is not French. This is either Japanese or Chinese. Right? It gives you an idea. So that's the essence of today, is so that when you see a programming language, you can have an idea like, okay, this is what it is, or it might not be, and so on. Okay.
Okay.
So the most important part for today, though, is the programming basics. Okay. What is it that we need to do? Just like any other language, right? You know, right now, in assumption, I don't know any programming language. You don't know any programming language. We are like kids that were just born. When you give birth to a child, the child only knows one language, crying. Eventually, you start teaching them, they start learning 1 or 2 words, and then start forming a sentence and so on. It's the same thing with computer programming. We need a syntax. In every language, there's a different way that the sentence is ordered. Maybe subject, object, verb. Every rule of every language, or every language has its own rules. So let's jump in and see what some of these syntax rules are for programming language. We are not going to talk about any particular language. We'll talk about all of them together to be able to come up with best, a good idea per se of how we can actually understand this. So let's see. I don't like this computer. Next time I'm going to have to use a different computer. This guy is not being nice to me. All right. Okay, so first thing with syntax, there are about 6 main things that we need to know about how a computer program is actually written, right? So just like English language, if somebody writes a sentence, there are certain things that you look at the sentence to make sure that it's good or bad. So I'm not going to use that because this is not being nice to me. I'm going to use this one instead. drag this over to that screen. Okay. Can you see that? Can you see my screen?
Yes, yes.
Okay, awesome. So here you can see when you're looking at the syntax of a programming language, the 5 main things we have to, well, main things, not, this is not everything for sure, is we have to check about the case sensitivity, okay? Check if there's capitalization. There's some programming languages that it's very case sensitive. Other ones, you can ignore the case. So you have to be peculiar. You know, just like in English language, wherever you start a sentence, you have to start with capital letter. Nouns, you have to have capital letters. If you're using the word I, it has to be capitalized. If you say you, it's lowercase and so on. And then statements. What exactly is a statement? In programming language, a statement is one instruction, right? Just like a sentence in English. So you have one instruction and so on and so forth. Now, when you write them, do you need white spaces in there? Are those white spaces significant? Each programming language is different. Some programming languages ignore white spaces, other programming languages do not. And then comments are also very useful, okay? Comments are that piece of your part of your code that is being ignored when you run the code that is not taken as an instruction. And then keywords, just like in English language, when kids grow up, you tell them, don't use this word, don't use that word, and so on and so forth. In programming languages, each programming language has its own reserved words, also known as keywords. Okay, so case sensitivity and capitalization. An example is the word true. If you see true written in lowercase, you have to maintain that case. Okay, if you change it to uppercase, it might give you an error when you compile or when you interpret your code. So you can have a compile error, one-time error, and so on. So here's an example. If you're looking at this, this doesn't really look good. You don't want to type code this way because, you know, the case will throw, I mean, it makes very difficult for you to read it. So some languages are case sensitive, you know, Pascal, Basic, Ada, Fortran, and SQL. Once you know that, you know, you have to be careful, but just be careful in general when you're writing code. Just make sure that you use the case the way it's used in other cases. So statement again, it's just an instruction. You might have to say, okay, for my coffee or for my food, add this, remove this. If it's a video game, display the player, add music, you know, play song and so on and so forth. So that's another example. So each statement though has to be complete, okay? Maybe you want to say change the background to light blue or add 99 to the current score or print the document on the default printer and so on. You know, that's an example, but that's not all about statements. You also have to make sure that there is a particular way that a statement has to end, just like punctuation. In English language or French language, you have punctuations. Is it going to be a comma or full stop or exclamation point? In different programming languages like Java, PHP, C++, and C, you must always have a semicolon at the end.
Okay.
If you don't have a semicolon at the end, it's going to assume that the statement is not completed. You know, so it might end up joining two statements and then it will give you an error. But when you see that at the end, then it knows it's not an error. But for other programs, Swift, Ruby, and Python, you don't need a semicolon, it's optional. So when it sees that you go to a new line, it knows that once instruction is gone, and so on and so forth. So they are all different. We have to just remember in a big picture. Now, one other thing to mention is pseudocode. Pseudocode is not actual code that you're writing. It's, for instance, when you go into that planning phase of your software development life cycle, you come up with the requirements, you decide, okay, while you're designing, the things that you need to do is, I need to display hello on the screen. I need to add 99 to the score. I need to do this. This is not code that you're writing. It's just things that are telling you how you need to approach your code. Regardless of whichever programming language you're writing, it might be like that. Some people write long pseudocode. Some people write short pseudocode. It depends on you and your preferences.
Okay.
So again, it's human readable statements before the computer readable statements. So whoever on your team or tomorrow or whenever comes to look at that code, they should be able to understand based on the pseudocode that this is what you're writing. So again, this is an example of pseudocode. They'll go on a whiteboard, say the entire team goes in, let's say, okay, we need to build a video game. When it's on the competition, we want to display at the end of the competition, or when the competition is going on, display congratulations message, play a trumpet sound, and so on and so forth. If they are going to reset the game, then go to reset game. If not, save the score, and so on and so forth. So if the game is finished, display this, blah, 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 blah. These are all the same thing. It's just pseudocode. It's not the actual code itself, okay? So based on that, you just go ahead and write that. The C programmer will say a function that does this. A VB programmer will say a sub that does this, and that's it before they actually go ahead, okay? Now, so based on that, once you have done that, you can then go in and say, okay, in this part of my pseudocode, I need to research that, because how do I play an MP3 file? Or do I need a best way of finding that out, and so on and so forth? So those are all things that will help you to be able to identify that. White space as well. White space is ignored in some programming languages, but Python is one that actually is very important. You want to make sure that you pay attention to your white spaces for Python. So for instance, if you look at this sentence right here and that one, they are totally different from when you add the white space in there. Some programs will ignore it, other programs will see it totally different. So you want to make sure that, even if you're adding blank lines or you're adding a tab, if they are ignored, fine, but just make sure that because you can do it, you want to make sure it's easy for everybody to read. Comments is also a good thing. So in this case, all the code has been blurred out. Just the comment you're seeing. The comment is actually being skipped. It's not being executed by the CPU. It's just for you to help yourself or any other team member that comes back. You'll know that in this part of the code, you are playing a live stream audio. In this part of the code, you're checking the internet connection. In this part of the code, you're resetting the volume, okay? So tomorrow you not be confused, like, why did I write this one? Why did I write that one? You already have your comments in there that's telling you what it does. And you don't have to try to understand what the code is doing. So again, the way you know it's a comment, in this case, it starts with 2 forward slashes. The different programs have different ways of writing comment. For C-style languages, they use forward slash. For Python and Ruby, they use hash. For Visual Basic, they use apostrophe. For others, 2 dashes, basic is when, and so on and so forth. But in some cases, maybe your comment has to take more than 1 line. If it's just 1 line, then you use 2 forward slash. But if it's multiple lines, you use 1 forward slash asterisk, and then you close it. Okay, so this is a multi-line or a block comment. So next up, remember, you don't have to really use a comment on every line. In this case, just by looking at this, you know that, okay, you're going to print thanks for playing. You don't need to go ahead and add the comment on there again. That's just wasting your time and space. And again, comments are also good to set reminders. For here, you see that the person has added a to-do. Means that they probably have not completed their code. They know they have to come back and display custom graphics there. Then this says fix me. So this does not display correctly on the right to left languages. So you have to come back and work on it. So they are just setting reminders for yourself. Okay. So here, maybe this is slow. You have to figure out a way to hack it, to work around, and so on and so forth. So comments, again, are very, very good. In some cases, You add a comment because you want the code not to execute. Maybe you already want it to, just like debugging, you comment it out and it's going to skip that part of the code. Sounds good?
Yes.
Finally, let's talk about keywords. Keywords, again, are those special words that you cannot use. For instance, if you're going to change a value in Python, you can use the score is equal to the score, you add 10. In this case, you're using add. Add is a particular keyword for COBOL. To is another keyword for COBOL. Set is also another keyword for script, and so on and so forth. If you need to ask a question, if the score is greater than 100, then you can go ahead and use the if keyword. Okay, you can use the GT keyword, and so on and so forth. Print is also another keyword. Display. So those are words that the language has reserved for itself to be able to use for particular things. So you cannot use it to, give a name of anything, and so on and so forth. So here are, I think about 30 or 50 keywords for Java. I'm not sure, but each language has its own number of keywords. Sounds good?
Yeah.
All right. So let me get out of this. Yeah, so that gives us, just the basics of how that actually works. Now, the next thing is for you to be able to, okay, there you go. So the next thing is we want to talk about how do you input data? How do you get data out of your program? There are many ways that you want to be able to do that, okay? Inputting data, you might be getting it from the cloud, you might be getting it from the keyboard, you might be getting it through audio, and so on and so forth. But when you input it, you have to be able to store it as something so that you can use it or change it, and so on and so forth. If you're going to ask the user to enter their username, what are you going to do with the username? If you're going to ask the user to enter their city, what are you going to do with the city? You have to be able to store it somewhere. In order for you to store data that you're receiving, you need a variable, okay? So variables, they are just like buckets, like a container. If you know that you're going to need water, then you need a bucket. If you know that you're going to open a bank account, you need an account number. That account number is holding that account that you're going to open, right? So variables have multiple things. They have three things actually. They have a name, they have a value, and they have a type. So the name, for instance, has to be something that is going to be useful, right? You don't want to just call your variable X, because X can mean anything. But you want to call it a member's name, or you want to call it name of city or city name. That way, when you look at it, you know that, okay, this bucket is going to have a city name, or it can be just a box. A box is going to be for shoes. This box is for clothes. This box is for dishes, and so on and so forth. But now, the variable again is just a container to hold stuff. You can always change what is inside the variable, and so on. Think about a bank account. If you open a bank account today with 100, it doesn't mean that bank account is always going to have 100. Tomorrow you can come and add, the next day you can come and subtract, the next day you can add, the next day you can subtract. It's just holding that. But if you want to call the bank, you have to call the bank and tell them, I need my balance for this account number. That's how you identify it. It's the same with a variable. When you talk about the type, the variable could have many different types. Think about census. When somebody comes to get your information or birth certificate or driver's license, you need things like your name, your date of birth, your age, your city, your profession, and so on and so forth. All those things. Are you married? Yes or no? Are you an organ donor? Yes or no? Are you in the military? Yes or no? So those are the different data types. Some variables are going to take numbers, but there are different types of numbers too. It might be a whole number, For instance, your age is always going to be a whole number, right? It can be a decimal number. For instance, if it's a balance in your account, it might have 1.0 or 10.3 and so on and so forth. You could also have a date. A date is a different data type. Okay, so dates have obviously just 12 months. Depending on the month, it has a number of days. It could also be a text. A text is usually known as a string. Why is it a string? Because it's like a rope with multiple letters on it. So that's why it's known as a string. So if you get a string or text, they are usually synonymous. But if it's just one, then it becomes a character. If it's fixed with, then it can be a set of characters that you know that it's always going to be 2 characters or 3 characters and so on. So those are the main things to know about. Once you have a variable, you can use that variable to hold your information. And what the variable is doing is it's actually reserving a space for you in memory, so that each time you need that, depending on the data type, if your data type is a number, it's going to reserve you a different type of space or different size of space. If your variable is a long text, then it's going to have a different size and so on and so forth. All right. So obviously you have operators as well. Operators are things that you use to be able to make changes to your variable. For instance, you can have addition, subtraction, multiplication, division. Those are all arithmetic operators. You can also have assignment operators, to be able to say, take 10 and assign it in this variable, take 20 and assign it to this other variable, so that you can make changes. So in some cases, you might not need to make changes. Maybe you want to say, create a football game and you need a number of players in the field. You can say maximum number of players in the field is 11. That's never going to change. So you can set your criteria, or you can declare your variable and give it to be 11. So in order not to go too much in depth on the coding per se, because we're definitely going to come back and work on 1 or 2 programming languages to be able to exercise all of this. Just storing the data is not enough. You have to also manipulate it, and to manipulate it, you have to be able to use flow charts, or, the flow of the program or program flow. So again, in this case, you might be able to say a situation where, you're giving instructions to a child to go to school, right? Normally, you write a computer program and say, okay, wake up, brush your teeth, eat breakfast, or sorry, wake up, make up your bed, brush your teeth, take a bath, eat breakfast, pack your books, go to school, right? So now it depends. Now you might have to go back and change your program, right? Because those instructions work only on Monday to Friday. On Saturday, you don't need a child to do those. So now you can add some kind of choices or condition, right? You can say, if today is weekday, wake up, brush your teeth, do this, do that, go to school. But if today is Sunday, wake up, brush your teeth, do that, and then go to church. So based on that decision, based on that condition, if this is that, do this part of the program. So your program does not necessarily have to go from top to bottom. There are some places in your program that are going to be skipped based on a condition. So if a person's bank account balance is less than 0, don't allow them to withdraw money. If the bank account balance is greater than 0, allow them to withdraw the amount that they are able to. So all of those you can set up to have as your conditions per se. Now, it could become more complex, right? When it becomes more complex, you have cases where you can use the or you can also use and. And even just for the conditions, you might want to be able to capture what happens if a condition is not met. That's when you would be able to use an if-else statement. If it's Saturday, then go to play football. Else, If it is Sunday, then go to church. Else, if it is not Saturday or Sunday, that means it's weekday, go to school, right? So those are some of the examples in which you can use choices or conditions to be able to make that flow. Now, in other cases, you might need to repeat certain instructions over and over and over and over again, right? For instance, if you're hungry, eat 1 spoon of gari. If you're hungry again, eat 1 slice of bread. So you can set it up and say, okay, if or while your hunger is equal to 0, or while you're no longer hungry, or while you're hungry, keep eating until you're no longer hungry. Or you can say, for instance, you want to divide some gifts to all the children in the room. So for all the children in this room, give 1 gift. So if there are 40 children, 40 gifts will be given. If there are 20 children, 20 gifts will be given. Or for each or for in is being used when you have a collection of items. So we haven't talked about collections yet, but that's something that I would actually want to skip that because it's more intermediate than not. So once you have all of these instructions that you have built multiple different instructions to make up 1 piece of software, you can then build them, or rather break this long code into reusable parts. Obviously, you're telling a story with your programming language code or software that you're building. But again, you want to be able to remove them. Each part has a unit that is highly cohesive and loosely coupled. Again, those are big terms just to say, you can reuse it, and you cannot only depend on one. If one is broken, the rest can also keep functioning perfectly fine. So you can create functions or modules. These are reusable pieces of code. Okay, you write a function, you let it sit there, and then you can use it over and over. It's just like a dishing spoon. If you have a dishing spoon, you can use it to dish multiple times, and it still stays the same. So again, as it's reusable, you can have parameters. Parameters are values that you pass to the function, which changes the outcome, changes the result. So for instance, you can have a box that has a label, right? That box is a black box per se, because that's what functions are. Functions are more or less black boxes that you put an input in there and an output comes out. In some cases, there's no input, you still get an output. In some cases, you don't get an output, you just get an input. So if you have a black box, you can call it whatever you need to call it. If you put water in the black box, you have pepper soup that comes out, then that's the function that it's doing. Another black box or another black pot, if you put water in there, mix the ingredients, whatever is in there, you have achu soup instead. So depending on what the function specification is, the function might say put a black, what do you call it, a kanwa, put this, put that, whatever you put in there is going to be incorporated in the output. So now you can have parameters in there. If you put 2 cups of water, that's the amount that you're going to get back, right? So again, those return values are more or less like the outcome that you get from it. Arrays and collections, and that's just data structures that are a little bit more complicated than just having one. Again, collection is having more than one. So for instance, you can have a list of students in a class, and then you can decide to add to the list or remove from the list. Okay, you can also have an array. An array would be like a locker. Okay. It has a set size, it doesn't increase or reduce. So in that locker, everything has its own space. You can decide and say, in space number 1, I'll put my math book. Space number 2, I put my English book. Space number 3, I have my geography book. And it's going to maintain that order. And then you can go in and say, for each space, remove the book, or for each space, do a particular operation on there. So arrays, you can have not just single variables, you can have variables put in sets. So each programming language has different types of collections that they use as well, but most of them have functions on them. You can decide to say, tell me what's the first value, tell me what's the last value, tell me how many values are in the array or the length and so on. So again, that's it in a nutshell on the modularity. The last part, which has to do with real world uses or scenarios of what we actually have in here as programming languages. Let's talk about that. Yeah, there it is. Okay. Do you have any questions so far?
No.
Okay, so let's jump in then to real world scenarios. So let's say you've learned this wonderful programming language that you like, you want to then go ahead and use it, right? But it's not really fun. You write a program and then you change it into a function, and the function is called draw pixel. The only thing that it does is it draws a dot on a particular position, which is 10 from the left and 10 from the top. Okay, 10 horizontal, 10 vertical. But that's it. Again, that's just a simple program, but you can build on it. It actually increases your worth a lot because you can decide and say, hey, I'm going to use one of the things we talked about, which was iteration loops, and loop it 10 times, right? If you loop it 10 times and say, okay, for every item from 10 to 30, I want to draw a pixel from 10, 10 to 30, 10. So it's going to draw one for each of them. And then eventually you end up having a line. Just with having this one code, one function that you have created, you end up drawing a line. You can even go ahead and decide that you want to be, creative and go ahead and draw not just a horizontal line, you can also draw a vertical line and draw a diagonal line. That's how programming works. At the end of the day, somebody is going to take that and make all different iterations. They're going to draw, I can take your code and decide to draw 4 lines and it becomes a square. Somebody else will draw 8 lines and it becomes a cube, and so on and so forth. Everybody keeps building on everybody's code. At the end of the day, you have what is known as a library, okay? Because somebody has taken the time to sit down and learn about all the different ways that they can program dates. And they have done it so well, they keep building on it. Another person has decided to learn how to sort numbers in order. If they give them 30 numbers, they can sort them using a particular algorithm. Another person has had a search function, how to manipulate strings or letters. All of those are known as libraries. So a library is a set of functions grouped together that do a particular thing, and that has been tested. And the good thing with programming is if you have done it, I don't need to go back and redo it. I just have to take what you have used and then build on top or change it according to how I need to do it, and life goes on. So it's very easy. So that's what a library is. You hear a lot of times, everybody would say, okay, I need to use a function from the library to do this and that with that code. That's exactly what it is. But then library could be different types of libraries. You could have general or standard libraries, the ones that we just talked about having math functions. If you have to write code for addition, you don't need to go and create an addition function. If you want to write code for division, square root, average, all those stuff, they're already built in there, okay? But then you also have very specialized ones. You have some libraries that you can use only for the web. You know that, okay, this library is going to give my background, it's going to make my button look nice, it's going to add a particular visualization on my web page, and so on and so forth. You have other libraries for audio. You have some for 2D and 3D graphics, and so on and so forth. So these are all libraries. Again, just like in real life, You go in, you take the code, you use it, and you're done. You don't own the code, somebody else owns it, and they're happy to share their code with you to be able to use it to write your program, make your life easy. Just like we go to the library and borrow books. We don't own the books, but we take the book, we study what we need to study, and return the book for someone else to use it. Okay. And then you always get a confusion between libraries and frameworks. In libraries, you actually go and utilize, take it, take the library and insert it into your code and use it. But with a framework, it's the other way around. The framework, as you can see around this dotted line, is already set. It's already put in place. It's like structure is already set up in a house. And then you come in now and decide, I want to paint this part, I want to add this piece, I want to add this piece. So you add your pieces of your code, of your program in a framework to be able to develop it. So you can have a web framework, meaning you can have a website that can be automatically generated. You just come in and put in your own code. Your code can say, put my picture here, put my video here, take my music and put it down here, take this and put it there. So those are the ways that a framework is different from a library. With a library, you go and borrow the library and insert it in your code and then do what you need to do. And then that's it. So libraries and framework, some people use it interchangeably, but it's good to know the difference between the two. Another thing we'll talk about is SDK. You hear that quite a lot. Software development kit. Back in the days, you know, when you want to create a program, you order, let's say, Java. It comes with a textbook with all these DVDs. You have to put the CD-ROM in your computer and install it before you can start writing Java programs and so on. So it comes with a bunch of things, tutorials on how to learn how to write it, emulator, you know, giving you like in this case, if it's Android comes with an emulator reference material, the tools that you need to program, examples of the code, these libraries and frameworks that we talked about, and emulator, so that you can actually see what your output will look like on a phone or on a screen and so on. So that's what the software development kit is. The next thing to talk about is API. API is, again, everybody knows application programming interface. It's actually the layer that actually helps you, the user, to interface, to interact with the computer or the program. Normally, let's say if a program, if you want to write a program that uses information from Twitter or Facebook, Facebook has an interface that you can use to connect to it and get your data from it. So application programming interface, again, just is an example would be when you walk into the room, you press the switch, the light goes on. You don't really know what happens behind the scenes. You just know that when you put the switch down, the light will go up, or you put the switch up, the light will go up. You don't know how the electricity works through that. If you're driving a car, you know that if you step on the brakes, the car will stop, but you don't really know the mechanics behind it, or you just know that stepping on the brakes, it will stop. So it shields you, it protects you from understanding all the inner workings of everything else. But just that, you know, also it's very well documented. You know, all APIs are well documented. You know that if you use this API, you get this. You use that API, this is your result. So that's what an API is. Now, what programming language should you choose if you have to start learning programming? Now that we've talked a lot about the programs and the programming languages. So I'll try to finish this in about 5 minutes so that we have some time at the end of the day. But in a nutshell, there are many different things you can do with programs, or different programs that you can use, okay? If you're going to work on game development, okay, video games and so on, then maybe Unity, which is C# and Unreal Engine, C++. If it's for web development, then you need JavaScript, Angular, JS, Ruby on Rails, ASP.NET. Those are mostly frameworks, okay? Or should I say, yeah, web frameworks. But you need JavaScript. HTML and CSS. If you're going to develop for mobile applications, software, mobile devices, then you need Java for Android and Swift for iOS. For enterprise applications, if you're going to work in a big company, one of these companies out there that use proprietary information, proprietary stuff, then it's either Java or C# or VB.NET. Okay. But for data visualization, most of the data stuff, if you're going to working with data, you definitely need Python or R programming. And there are also some specialized areas that others might be interested in. But that said, the one thing I wanted to also point out was it's a nice schematic. Even though it's old, I think it's still very good. You can't see it now, but let me zoom in. So what it actually says, this was in 2015, I believe, 2014, 2015. This is just an infographic asking which programming language should I learn first? So what is programming? It's just writing very specific instructions to a very dumb yet obedient machine. Most people say that computer is very smart, but computer is not smart at all. Computer is very dumb. Computer is just very fast. To be very fast is different from being very smart. So it's very fast. It can process a lot faster than us. Okay. So why don't we just use it and give it the right instructions to perform all these things? Because what does a computer need? It does not need food. It does not need anything. It just sits there. It's waiting for instructions. Computer just needs instructions each time. So in order for us to do that, we can use any of these programming languages. Here we have Objective-C, but Objective-C has been replaced with Swift. So that's what you see. So if we start here, okay, and you ask the question, why do you want to learn programming? If you want to learn it for my kids, you should use Python. So here you can see this blue icon is Python, JS is JavaScript, the coffee with Vapor is Java, and there's C#, there's Ruby, there's C, PHP, C++, and Objective-C. But then if why you want to learn programming is you don't know, pick one. Python again is still the right answer. So you see that Python is the answer for some of them here because it's easy and it's very readable. But if you want to just do it for fun, then fine. If you're just interested or you want to improve yourself, then okay, you get to answer the next question. Do you have a brilliant idea or do you have a particular platform in mind? No, you don't have a brilliant idea. Then fine. Do you prefer to learn things the easy way? Then do Python. The hard way, the best way, do Python. The slightly harder way, if you like automatic car or manual car, and so on and so forth. But now, if you have to choose a platform, depending on the platform, is it going to be for 3D gaming? Then you should use C++. Is it going to be for mobile? Then you should use, if it's for iOS, then Swift. If it's for Android, Java. So basically the same thing that we're talking about, but this breaks it down in a fun way for you to see. If it's for web, you definitely need JavaScript. Okay, and so on and so forth. So this breaks it down for you all the way here. It's also asking you, is it for corporate? If it's for Microsoft products, then use C#. If it's not for Microsoft products, use Java, so on. So depending on what your company does. So that's just it in a nutshell. I have all those links in here for you in your notes. Once you get in there, you can always get all that information. The last thing was editors. We talked about it, IDEs. I'll talk about that in the next class, and then we can see how you can use IDE. Is just an integrated development environment, which helps you in writing your code faster, better, and also packaging it all together so that you can release it out to your end user. Okay. So I think we covered everything we needed to do today in 90 minutes, just as we had planned, which is impressive because this is a lot of stuff to cover. I know it's a lot of things everywhere. But what questions do we have? At least, does this give you an idea of what software programming is about?
Well, everything that is new to me. I'm just getting things there. I need to process them. I need to listen about 2 times to process them, really.
Good, good, good. Yes, the meeting is recorded, so you definitely have a copy of it to go back and review it. And it's better to actually, all the talking is you're going to forget. But once you start getting in and typing and making those mistakes yourself, then it's going to get better. And from there you be able to whip and see what your results and your outcomes are.
That's right. Like I started with the first class that we had. I've gone through it. I started with the second class. So I could not go through the second class. So I'm going to go through all of them gradually to get all what is happening, follow up.
Exactly. Then you'll be well placed then to, especially remember the terminology. That's the main thing. You can't remember everything now, but if you remember the terminology, here and there, you should be very, very good. Very good.
Yeah, I appreciate it.
No, you're very welcome. All right, Everett, let me let you go and enjoy the rest of your Saturday.
Thank you very much. I'm very grateful.
No, you're very, very welcome. Very, very welcome. All right. Have a wonderful night.
Thank you.
Okay.